Welcome back, fifth grade. Hey, welcome back. Mr. Porter here. I really miss you guys. I hope you're staying safe. My biology teacher in high school used to say it's not a matter of if, but when a virus like the one that's happening now would inflict the world. He just knows that's true, and he was right. It's not a matter of if, but when things like these happen. Don't worry. Be safe. Wash your hands. Stay away from strangers. Keep some safe distance. It'll be okay. If you ever need anything, please reach out to us. We care deeply for your well-being. Seriously, we are here for you. Okay, let's jump right in. Last week we did some review over the cell, as well as cells to tissues to organs to systems, and then specifically the skeletal system. So I want to go over that today. That way Monday we're ready to go. Okay, let's jump right in. All right, welcome to Mr. Porter's science class. This is one of my PowerPoints, and now you've missed it. Let's get started. All right, so you should have a science journal. I'm assuming yesterday, today being Thursday, yesterday you should have picked up your things from the NPR, from your locker. If you don't have your science journal, go get one right now. Okay, go get one right now. Go ahead and pause the video and get that figured out. You should title your journal with the date, as we've done up until now, with the title of the lesson today, Human Anatomy, Skeletal System. Okay, so go ahead and pause the video and write down those notes. Cell, the tissue, to organ, to system. Okay, great. Did you pause it? Awesome. All right, so from smallest to biggest, we have cell, which is the smallest unit that all living things are made up of. We, being living things, are made up of cells. And then many of those cells together make tissue, and then a bunch of tissue together makes an organ, and then a bunch of organs all together can form systems. Got it? Great. Let's go. So let's look at cells first. We're going to look at these individually. So here's a model of an animal cell. Now, you guys created one of these the first week of third quarter. You guys did an excellent job. Now, the model, I want to point out, a model isn't the real thing. A model is just something to help you learn. It's not the real thing, okay? So it much like a model slash actor is not something we want to necessarily aspire for. It's just something we see on TV, okay? So don't think that that's the real thing. Models are super skinny. No one is really that skinny. In the same way, cells, these models, are not really the real thing, just something to help us understand the real thing. Got it? Okay, great. So when you, and me as well, and anyone else who's alive, was forming, when we were forming in our mother's wombs, we were all just originally a small clump of cells. We seemed just to be a couple cells all forming. But just within a few days, all of our cells start to specialize, okay? And so we're made up of a bunch of different specialized cells. So let's look at some of those. So some of our cells turn into heart cells. So this obviously looks a lot different than a heart that we all draw. Hearts are really awesome. They also look kind of gross, but they're really, really awesome. And so we can see here, this is what heart cells start to look like. Here's a bone cell. We call this an osteocyte. They start to look like this. They have their own functions, right? So we look at a bone up close. This is how it might look like. Here's a lung cell. This is what the virus has been inflicting. Lung cells are really cool to study as well. And this is pointing out blood vessels, which are veins or arteries, and then our alveoli, which are the little pockets which contain air, which our lungs use to store air for oxygen. Okay, and lastly, we have, well, that's cool effect. Try that again. Whoa. Whoa. Okay, cool. Brain cell. So these are brain cells. These are what we call neurons. So notice how all of our cells start to look different based on where they're at in our body. This is because our gene code tells our body to develop certain cells certain ways. They can perform different functions. Just like some of you guys are really good artists, some of you guys are really good mathematicians, some of you guys are really good scientists, some of you guys are really good at sports, and some people are really good at construction, some people are really good at teaching. That's me. I'm really good at teaching. Some people are good at being engineers, and the list goes on forever, right? Some people are really good at being scientists. So we all specialize just like our cells. All of our cells are specializing to perform different functions, all of which work together within systems so that we can live. So your cells are working really hard just for you even to be sitting here watching this video. Okay, so here's a liver cell, by the way. Speaking of specialization, so we remember lysosomes, right? I hope you remember lysosomes. Lysosomes are the part of the cell that break down toxins. What do livers do? They break down toxins. So liver cells will probably have lots of lysosomes, a lot more than other types of cells because other types of cells don't need as much to have to break down toxins. Livers specialize in breaking down toxins, so they're going to have lots of lysosomes, lots of peroxisomes, lots of things that are going to help them break down the bad stuff so the rest of your cells don't have to do that. Okay, so these are cells. We're made up of these cells. Specialization, awesome. Okay, so we talked about cells. Now let's talk about tissues. Talk about cells. Let's talk about tissues. So tissues are when we see groups of these cells all together. So we have bone tissue, muscle tissue, nerve tissue. So if we were to take a little slice out of our bone, a little slice out of our muscle, a little slice out of our nerves, we might see tissue. And right, look at all these. These are a bunch. You can see all the nuclei here. These are a bunch of different heart cells. In other words, this would be heart tissue, the whole thing. These are a bunch of different lung cells. This is lung tissue. Bunch of different bone cells. This is bone tissue. And as you can see, about 3 or so brain cells here. This is still brain tissue. Okay. So we have cells, we have tissues, which are many cells. We have organs, which are all the tissue. So all of the neurons together form the brain, the organ, or all the stomach cells form the stomach, or all of the heart cells form the heart. And lastly, what we want to talk about today are systems. In particular, we are looking at 8 systems. We'll see how many we can get through this quarter. We won't rush it. We'll just see what we can get through. But most importantly, what I want to focus on is the skeletal system, which is all of your bones, right? If one bone is an organ, then the entire system, your entire skeleton, are all the bones, okay? So we're going to look at the skeletal system as well as the muscular system and how they interact. So let's go ahead and do that. Skeletal system. All right, go ahead and pause the video, take down these notes. Did you pause it? Great. I'm assuming these are already written down in your notebook if you're still hearing my voice. If you're still hearing my voice and you haven't written these down, pause the video, do that. Skeletal systems, 3 main jobs. 1, provide structure and support. 2, protect your organs. 3, work with muscular system to move your body. Let's look at all 3 of these. And one more time. Provide structure, protect organs, work with muscular system. Okay, let's go ahead and look at all 3 of those functions. Starting with the first one, structure and support. Okay, so your worksheet had an awesome analogy of the frame of a house. Yes, so a skeleton is much like the frame of a house. Now, I want you to look around at your house or your apartment, wherever you live. I want you to look around and notice that you can't see the frame. You can see the walls, you can see electrical outlets, you can see windows, maybe the door, but you cannot see this frame. All right? Now, I want you to imagine that that frame didn't exist. What's going to happen to your home? You can't see it, but it's important. If the frame didn't exist, your walls would fall over. Your walls are drilled into those frames, okay? The drywall is drilled into those frames. The floor sits on the foundation. The windows that we can see here in this picture would not be there. They would fall and break. The frame is so important. That's obvious. The same thing goes for your skeleton. This is the frame of your body. You can't see it unless you're a little bit skinny. I can kind of see my ribs, but that's becoming progressively less true over time. What I'm trying to say is I'm getting fat. So your bones are super important, although you can't very much see them. They're so important to act as a frame, much like a frame of a house, okay? And just like a house needs a frame to have piping and the electrical system all interconnected through it, your body, much in the same way, has piping. Think of your veins and your arteries, and also has an electrical system. Think of your nerves. Yes, that is very much an electrical system. All right, so let's keep going. All right, so that's the first point, structure and support. Moving on. We have the second function of the skeletal system, to protect your organs. Now, this is a fake brain. Don't be worried about that. This is all a model. Again, it's a good model. Oops, going a little too far here. The skull, imagine if you did not have a skull. The skull is there to protect the brain, but if you didn't have it, imagine anytime you've ever hit your head in the past, and I'm sure all of us have hit our head recently, or at least in the last year. Imagine if we didn't have a skull. That would often cause permanent damage to our brain, and a lot of us would have severe disabilities just because we didn't have some kind of layer of protection around the brain. Okay, so any kind of injury to the brain will really harm you. So having a thick skull is super important. And in the same way, the ribs will act to protect your lungs and heart, right? So our bones, one of its main jobs is to protect really sensitive organs like our brain, lungs, heart. Okay, so our skull and as well as our ribs are doing an awesome job protecting us. Now, what I want you to ask yourself for a second is what, if that's true, if the bones are there to protect the organs for the most part, that's one of their three functions, what does the spine protect? Go ahead and pause the video and try to guess. Okay, the spine protects did you guess it? The spinal cord. Ooh, okay. So, the spinal cord. So the spine protects the spinal cord. Super important. The spinal cord is an extension of your brain. So your brain, if you go ahead and move your arm up and down like I'm doing right now, you can't see me, but I'm moving my arm up and down right now. Your brain will be sending signals down your spinal cord through, for your arm in particular, one of your thoracic nerves, or many of them, causing your arm to move up and down. Okay. And then if you were to perhaps maybe get a cut on your arm, then a signal might be sent back from that cut all the way up to your brainstem. I'm sorry, all the way through your spinal cord up to your brainstem, up to your brain, and then you would say, "Oh my word, I have a cut. I need to get that taken care of." Okay, so your spinal cord is super important because it's an extension of your brain. All right, and so here is a representation of your spine, which are the bones that protect the spinal cord. So this is protection as well as support. Okay, that's why it's super important that you, especially if you're a lady, if you are eating lots of calcium, you'll find this in milk and especially in big leafy greens, not iceberg lettuce, but probably romaine lettuce and things like that. Okay, so big leafy greens provide lots of calcium. Super important that you are taking in calcium to strengthen your bones now, because the more you strengthen your bones now, the more bone you'll have for later in your life. For those who don't strengthen their bones, well, you kind of end up looking like this when you get old, okay? And I'm not trying to make light of this. This is not a fun situation for anyone who's old, but definitely important to avoid this. And so what you see here is someone who didn't actually take in a lot of calcium at a young age, and especially if you're a lady, as you get older, for reasons we won't talk about now, your bones in your spine start to break down. So that structure and support, that first function we talked about, starts to go away, right? Because your bones are starting to break down just like the rest of your body, okay? And so if you don't have a lot of calcium stored up at a young age, um, if you don't have a lot of calcium stored up by the time you're 30 years old, then this will happen to you inevitably by the time you're old, okay? This is what we call osteoporosis, all right? The breaking down of the bones, okay? So that all of us are prone to this, especially the ladies. So make sure you're taking in lots of calcium now. Be smart about what you're eating. It matters. It matters a lot. And lastly, the third function of the skeletal system is to work with the muscular system to move. Okay. So first we talked about how the skeletal system is like a frame for your house or for your person. The second is that it protects your organs, and the third function of the skeletal system is to help you move, working with the muscular system. So I want you to think about your bicep for a second. Go ahead and extend your arm out just like this, and go ahead and feel your bicep right here. All right, and so I want you to notice how bones provide a place for muscles to attach. It's an attachment point. There are attachment points on the bones for the muscles to move. Okay, so muscles for the bicep in particular attach to the top of the humerus and then to the radius bone down here. These are the names of these bones. And so when you flex your bicep, what the muscle is doing is it's pulling the radius closer to the humerus. So bones act as attachment points for your muscles for movement. Okay, that's the third major function. All right, so we'll cover that in more detail on Monday. I hope you've enjoyed this recap. Go ahead and take a look at the homework in a little more detail, and feel free to reach out to me if you have any questions during my office hours. All right. Hope to see you next time.